Thanks everyone for coming. I guess we're going to get started. So my name is Aaron Newman. I'm the founder of a company called Cloud Checker. We do visibility and control of what you have run in your Amazon environment. And that visibility and control goes across cost, security, usage, and availability. So security is really a big piece for me. I've had multiple startups around kind of the security industry. So this is very interesting. And really what I'm here today to talk about is really how do you understand and take what you know in your data center and apply those security principles into your cloud? What's different? What's important? What do you need to understand? How do you need to think about things differently? So we're going to go through a lot of that today, try to draw some real examples. And what I hope you walk away with today is a real understanding of what's different about the cloud. What is it that's different about Amazon? What do I have to do to go home and make sure that I don't end up hacked, that I don't end up, and hacked means a lot of things. That could be anything from an admin doing something bad to an external threat, anything like that. But we want you to understand much better what's the real threats, what's my perspective, how does the world change as I move things into the Amazon cloud? So, the important thing is changing your perspective. The world really is different, but many of the same principles. The security world has matured over the last 20 years, and there's a lot of principles and things about how network-based IDS, penetration testing. These are all things that are very well defined at this point. But what they do is become much cloudier as we start to look at Amazon. We start to say, well, how am I going to do network-based IDS in the cloud? We all know if you want to get PCI compliance, if you want to pass a SOX review, if you want to do any of these compliance things, or if you're just trying to keep yourself secure, some of these solutions are very critical that you have to do if you're running a business app. And whether that's in the data center or in the cloud, I have to do it. And the question is, how do I do those things? They're very different when I'm running in the cloud than when I own my own hardware. So how do I think about the perimeter security? Perimeter security in your data center was I know right where my perimeter is. I find my firewalls. I find my wireless access points. Totally new world when you're in the Amazon cloud. It's really very different as how do I assess what my perimeter is. You do have to understand your perimeter if you want to secure your data. So we just need to think about things from a very different perspective and try to understand them. So in the data center, what was you set up your perimeter security. That means setting up your infrastructure. You put it behind a firewall. You set up access points. And then at those access points, you put security controls there. You put things like firewalls. You put IDS. You put intrusion prevention systems. You put all these access point security devices. So when you wanted to audit your security, you'd gather up, okay, I know what my public IP addresses are. I know what my blocks are that I own from my colo host provider, whoever it is. I gather those up and then I start poking at them. I poke at them by doing things like port scans using tools like Nmap. I look at vulnerability assessment tools. I hire a pen testing team to try to break into that. I figure out what's open. I try exploits on open ports. I sniff a lot of packets to see what's going on. Dig around for things like who's hosting a wireless access point from their office is not properly secured. Is there secondary T1 lines? These are all the standard things that somebody does to assess perimeter in the data center. Now, most of these don't make sense in terms of as you move into Amazon Web Services. So what's different? So there's a lot of things different. Well, the first thing is your physical asset security is entirely different. Amazon has that for you. They've gone through extensive reviews, and they have the most tightest security you can imagine. And I think it's interesting. I even had a conversation. They have data centers. They're in unmarked buildings. Nobody really knows where they are. Somebody does, but I think it's like 3 people literally know where they are. Even people, I had a conversation earlier a couple weeks ago with Jeff Barr, and I said, I would love to go into an Amazon data center and see what it actually looked like, because this is cutting edge technology, and he doesn't even get to go into them. So if he doesn't get to go into them, nobody's ever going to. So, even he said, I'd love to go into one, but they're really just, you build them and then it's all mechanical. It's almost like they have one security guard and a dog, and the dog's trained to bite the security guard if he tries to do anything. So it really is. So physical security, Amazon really has locked that down to a point where it's really, really secure. But what changes? So we do still need to guard the Amazon Web Services API. That API has basically become physical security for us. It used to be, if somebody is trying to break in and steal a hard drive, they would have to break into your building, jump over your gate, break through whatever, go into your server, and pull out a physical hard drive. That's what physical security was. Well, the same concept applies, right? You don't have to worry about somebody jumping over Amazon's fences and stealing that because the security is so tight. But you do have to still worry about if they get IM access. If they get that, then can they copy an EBS volume somewhere else? Can they steal that? That's the same. Copying an EBS volume is the same as somebody picking up a hard drive. Taking a snapshot of an RDS database is the same as somebody loading up your database server in your data center and driving away with it. So it's just really a different perspective and a different way that we need to secure things. So IM access becomes your physical security. And the idea of physical security morphs as infrastructure becomes virtualized. In the new world, you have these ephemeral assets that are being auto-scaled up and down. They're changing on a constant basis, and we need to think differently about our architecture for both compliance and security threats. So does that make sense to everybody? So a lot of the principles don't change, right? So what do we want to do when we want to protect ourselves? We want to reduce our surface area. What that means is the less surface area we have, the less things that people can attack, the more secure we're going to be. We want to practice principles like defense in depth. So you always have to assume that somebody can get past your perimeter security. Somebody's going to get past one layer of defense. They're going to get past the second layer of defense. You even have to assume maybe they can get past the third one. So you have to make sure you have as many defense levels as possible to keep the hacker out. So those are principles that don't change at all. But some of the things do. As well. So we have attacks. What type of attacks don't change? Application level attacks. So if you're hosting a web application, whether it sits in Amazon or it sits in your your own data center, it's vulnerable to things like user privilege escalation. It's vulnerable to cross-site scripting. It's vulnerable to SQL injection attacks. These are all things that are generic no matter where your physical assets sit. Your operating system vulnerabilities, same world. You have to scan your operating systems to make sure that they're patched. You have to scan your databases to make sure that they're patched. So those are all things that don't change. But some things do change, and these, the first thing is that you really have a very different capability to sniff. Sniffing was very critical to security in your old data center. You'd sniff packets to do everything from watching for attacks, understanding what people are doing, monitoring activity. You don't have that capability because you really don't own the network in an Amazon environment. You're really sharing the network. So you can't have the ability to just put a network device in promiscuous mode and see everything that's going on. So now a lot of people do things like, well, I'm going to try to funnel all my traffic through a NAT server. I'm going to try to funnel all my traffic through various mechanisms that do that. And that's good to do. You absolutely want to try to do that when you can so that you can set up these devices on it, monitor what's happening. But it's not really a practical solution, as the problem is, you can get lots of different things that just bypass. If I just set up one throttle point and I say anything that goes through that I'm going to monitor, there's just too many avenues around it. So it's a good thing to do, but it definitely doesn't give you total security. So what are the other things that change? So you want to think too about a homogeneous environment. So there's advantages to, you can have a homogeneous environment, which means everything is very similar, or you can have a heterogeneous environment, which means a lot of different varieties of operating systems, platforms, hardware, all that. So what do we see? The cloud is very much closer to what I would consider a homogeneous environment, because you're going to, you can easily take one AMI and you could spin it up 1,000 times, and you have this huge environment, but they're really all based off of one very similar image, one very similar configuration, one very similar set of patches. Good and bad, right? It's very good in that you can secure that, you can do a lot of work to secure that very, very well, and you can do a perfect job with that. then all 1,000 of your servers are perfectly secured. Now the problem is that if one unpatched vulnerability happens, then all 1,000 servers are actually vulnerable to that. So you see the good and the bad about that is if you do everything perfectly, then you're really in good shape. If you don't, then you're not. But the problem is that being perfect is really hard, right? That just means one mistake affects everything. Polymorphic targets, what does that mean? So what it does mean is that if somebody does attack an EC2 instance and breaks into one of your EC2 instances, in the cloud world, things are scaled up and down so quickly. If somebody does break in, they don't have access for months and months and months because that server could end up going away and they no longer have access. So really this idea of some attacker comes in and it's going to map your network. Well, when your network is changing so quickly, it becomes very hard to do that, and there's not a lot of value in it. So it just changes a lot of the factors. It makes the attack a little bit harder if they can't map it because it's changing so much. It's not as well defined. But you have to think about that homogeneous environment and make sure you're going to put a lot more effort in securing one AMI and then spinning that out all over. What was some of the advantages of, you think about an old corporate network where you had some Solaris here and you had some Windows here and you had this and that. If somebody broke into one piece because there was one exploit on some box, they were very limited. They could get there, but because everything else was different, they need a whole different way to attack and own another box in your environment. So that was kind of the advantage of the heterogeneous environment. But what it meant is that because you had so many different combinations of things, that there was a lot of opportunities that somebody would make a mistake somewhere. So it was very hard to secure everything perfectly. Perimeter assessment in the cloud. So how do I assess my perimeter in the cloud? Because what is your perimeter? Amazon has their perimeter. They have their outside, but you're shared with everybody else. And you have to assume that you're actually shared with the bad guys, right? You have to assume that the bad guy can open an AWS account, sit on the same box as you. So now there's virtualization and firewalls that the software runs. So you have a lot of virtual security going on. But beyond that, you have to think about what's the perimeter of my cloud. And when I say my cloud, your little world inside of Amazon. In the old world, somebody would take an Nmap, which is a tool that you can go scan. You'd do port scans, you do ping sweeps, and you'd go to the network administrator, and he'd give you what the network blocks are. So here are 5 network blocks. Go test and make sure there's no security holes in that. And then you just scan straight across to all those IPs. You can't do that in the Amazon world because the IP addresses are just, they're not contiguous. They're not. They're not something you could just scan like that. So in the new world, what do you do to assess your perimeter? You really want to figure out what are all my publicly accessible resources. And now that can be a lot of things. It can be everything. You have to think about it. There's S3 buckets. That's part of my perimeter. There are security groups, routing tables. There are IAM policies. These all are what make part of my perimeter and my publicly accessible resources. So you need to know all these things. So it's not just being an EC2 expert. It's being an S3 expert, understanding the security module there. It's understanding how VPCs work, how routing tables work. All those interact together to form your perimeter. So, and we're going to talk a little bit more about that. But it really becomes a complex task to understand what are all my publicly accessible resources, how do I secure them, and how do I make sure I don't have an opening in any of those? Let's think about, to start with, running a pen test on AWS. Pen tests are a big part of any PCI compliance you want to get. One of the big rules in there is you must be running pen tests on a regular basis. You must be running vulnerability assessments on a regular basis. So you're going to have to do this on your resources. Now, Amazon has done a great job of giving you the capability to do this. And rightfully so, Amazon is in an interesting situation in that they want to provide the security and the capability to secure the assets to the people that own it, but they also want to limit what you could do to damage other people and what the hacker can do to get in and damage you. So they're really balancing the two sides of it. And how do I give my user the ability to run pen tests on his own environment, but not have malicious people running things on there? So they have this website where you have to go and submit a request to do penetration tests against your own environment. And that way they actually have, and I don't know this for sure, but I can surmise most of this, is they have all kinds of their own intrusion detection devices, and they have a lot of sophisticated technology that protects you, and when somebody does do what looks like an attack, they can shut it down. Now, if you're trying to do a pen test on your own site and they're shutting you down, that causes problems with the effectiveness of your tests. So they give you this, this note or this website to allow you to submit requests to say, okay, I'm going to start doing things. You're going to start to see some things go off, like bells and whistles go off in their IDS system, but that's okay. Basically, you're saying that's okay. So now there's caveats here. So you have to understand, some of the things they do is they limit you can't run your pen tests and your any of your vulnerability assessments against M1 smalls and T1 micros. What does that mean? And that's probably because at the end of the day, those are much more shared devices. They're smaller, they're on the same boxes, so a pen test you run against your T1 micro could possibly affect the other people sitting on that same physical hardware. So you have to be real careful. They don't want you to do things like that because it can adversely affect things. And you need to have a lot of information about it. And this is where it's interesting too, because if you're hiring a company to come do a pen test for you, typically that company doesn't want to, they don't want to tell you, okay, I'm going to attack you this way to see whether there's a security hole, because that kind of invalidates the test. So, but when you're working in the Amazon environment, you have to gather that information. You have to know what the IP addresses that you're going to scan are. You have to know what instance IDs you're going to scan. You have to know the source of where they're coming from. So there becomes a little bit of a coordination of making sure if you've got an outside vendor doing this, they're going to have to coordinate with you to set all those up. So we're just going to jump out real quick into what does that actually look like? What is that? So here it is, penetration testing. They have a fairly detailed description of everything. What is all the permissions you're required, authorization. And now when you submit this as well, you submit it for a time period. So you can actually submit up to 3 months time period, which is a pretty wide time frame. So, and within this, you then, some of the rules, don't test on my M1 smalls or T1s. And then here's the link to drill down into it. And then you have to enter information like your company name, email address, your accounts you're going to be doing, and then scan information. So you really need to gather all your information like your IP addresses you're going to scan. Are these source or targets? What's the instances? What's the source that's going to come from? What region? So there's a lot of details you have to provide here. And then there's, of course, fairly restrictive terms and conditions, and you have to be careful. What you don't want to do, if you're using a tool, for instance, like a Nessus, there's lots of things you could do in there that are like banner grabbing to look for versions. They're fairly benign security tests, but there's also a lot of things that are fairly malicious security tests. What they'll try to do is basically shut the server down. And now you have to be careful running these, because in your own environment, it often is useful to be able to say, well, let me see if I can crash this, because I want to crash it before an attacker can crash it. What you want to do is make sure you never run those against your Amazon environment, because it's shared environment, you don't have the luxury of trying to do that. So you need to make sure if you're running a third-party tool that you've gone ahead and set some of those, and they describe most of that there. What's not limited, what you can do. You can't do protocol flooding, you can't do resource request flooding. Those are all part of standard denial of service attacks, distributed denial of service attacks. So you just have to make sure you're not going to violate any of these, and that you're very polite in your vulnerability assessments and scans. So, and that's, one of the really great and powerful things about using an Amazon Web Services is that distributed denial of service attacks. These are where people will go out there and take bots, thousands of bots, point them at your website, flood you in some pretty malicious ways, and basically just overwhelm you. So now to handle that in the real world is a very expensive and complex task. And typically that's a 6 or 7 figure type of security solution to go out and fix that problem. Now, out of the box, Amazon they've wrestled with that. They've wrestled with that, and they know how to handle those type of problems. So they take a lot of those distributed denial of service attack problems off your plate. So it's really great. So, but it also means that you can't go doing your own, protocol flooding and, all kinds of malicious denial of service capabilities. You can't do that against the website. You have to be careful when you do that. So what does that miss? So that's important and that's great, but what it doesn't do is you have to think through the EC2 is not the only attack surface. So you have to start thinking to yourself, hackers find the single weak link. So if you've really locked down EC2 well, attacker, put yourself in the attacker's standpoint. What's he going to do? He's not going to go after where your strength is. He's going to go after your weakness. So if you've locked down EC2, done all your penetration tests, all your vulnerability scans, done a great job there, but you totally forgot that S3 was a whole different subsystem with all this valuable data, that's where the attacker is going to go after. So think through not just what's my attack surface for EC2, but what's the rest of the attack surface? Where's the weak link somebody can identify and go after? And the truth is, Amazon is a very robust environment. It has over 30 services. There's a lot of moving parts there. At the end of the day, there is not a security feature that's not provided by Amazon. And that's a very broad statement. It's a little exaggerated, but the truth is they have so many security options that there's nothing that you can't prevent. But the truth is what you have to do is it's our job to properly configure that. And when there's 30 options, there's a good chance we screw something up. So that's the real threat. The threat is not the technology. The threat is the people and the processes around the technology. That's where the security ends up failing, is not because we don't have SSL capabilities. We don't have encryption capabilities. It's not because we don't have all these great capabilities. It's because we as humans forget to enable it on that server, or we didn't understand that there was a public IP address on this server, and I put it in the wrong security group, and bam, I'm exposed. So that's the real threat around computer security. It's not at all, this SSL version has a weakness in the cipher. That's almost never the real security threat. It's the human, it's the people in the process that's your real security threat. So, Amazon has over 30 different services. So it becomes, you have to almost be an expert, and not an expert, but you have to know all the permissions, capabilities, access controls, how to secure each one of those. And if you secure 29 of them and leave the last one exposed, then you're wide open. The hacker really only needs one avenue to get to your data. He doesn't need to make you to make 5 mistakes. He needs to make you to make 1 mistake. So it's much more important to have all those services covered than to go too deep in one single service. So, some companies, we have clients with customers with hundreds of AWS accounts, even 400 or 500 AWS accounts. And so what does that mean? As a security professional, it's very easy to lock down one account. But how do you lock down 100 that are being managed by 100 different disparate AWS admins, DevOps across my environment? That's the real challenge, is how do I make sure, and I see this on a regular basis, is people have S3 buckets that are wide open, and not to list, but to edit permissions, to overwrite, things like that, because they just haven't thought through and they don't understand the security ramifications of that. So if you're working for a big organization and your security policy doesn't allow that, the biggest problem is how do I go find that among 100 different accounts out there that are just being run disparately, decentralized. So it's important, one of the things you want to do is figure out what's your complete inventory. What's all the assets I have out there? How are they all configured? These are the type of things you need to do to find that weak link and eliminate the weak link. What are some of the, we're going to go through a couple of the services just to show you some of the different things you got to think about. So EC2 Classic, because we typically think about VPCs. VPCs is a core security piece of Amazon. It's really robust. It gives you a lot of capabilities. but we have to make sure we're using it right. So to start with, EC2 Classic. So pre-VPC era, this is how you got your EC2. Each EC2 instance was basically an island of its own. VPC is really great because it puts everything into one shell, and you can secure that one piece all together. Now, in the old world with EC2 Classic, each instance that you spun up was basically sitting on its own. It had to have its own security groups associated with it. There wasn't a unified way to protect it. So it really made things a bit more challenging because one security problem somewhere can cause all your issues, can expose you. Versus at least in a VPC, you have a VPC layer where you can try to at least filter out most things. Then within that, you have your second layer defense. You have security groups. You have routing tables. You have all these levels of security. So at least if your VPC is secured, even if you screwed up one of the EC2 security groups, you still have some level of protection. In the old EC2 Classic, it was a little bit more challenging. One slip of a security group could expose you totally. So the thing to understand, and I'll often talk to people, and they don't realize that in the old EC2 Classic, each instance, even if you don't put an elastic IP address on it, it still has a public DNS. It still has a public IP address. And that can end up biting you if you don't realize these type of things. So understand your EC2 instance has private IPs, public IPs, elastic IPs, and all those can become attack surfaces. So treat each thing sitting in EC2 Classic as a target with its own risks. VPC took security to a whole new level, very, very powerful. Understand by default, VPCs are wide open, so you have to actually go in there and specifically turn them on, basically set the rules to be much more restrictive. So that's something you should definitely do. As well, VPCs have a lot of components to it, and they can be complicated, right? Because you have internet and customers or VPN gateways. These are what connect to the rest of the world. Within the VPCs, you have subnets. Those subnets have routing tables that allow you to route things both internally and externally. It has network access control lists. These are your firewalls. And they're firewalls, but they're stateless firewalls, which makes it a little bit more interesting. Versus security groups, they're much like host-based firewalls, but they're stateful. So you have to understand those terms and what does that mean and how am I going to configure those. And then within the VPCs, you have your resources. And your resources can be EC2, RDS, Redshift, Elasticache. Those are the type of things that can sit inside of a VPC. So you always want to try to put your resources inside of a VPC, but then you have to make sure that you configured all these other things just right to not expose yourself. So Amazon can be super, super secure unless you screw up one of these steps. So that's your key, is make sure you don't screw up one of those steps. Understand how all these interact. Understand what it means by being stateless versus stateful. Understand my strategy is I'm going to implement 80% of my security at the network access control list, and the other 20% is going to be security groups. Here's my strategy. You need to understand your strategies, then you need to enforce them. So then you start to see things like S3. You surely probably have a lot of sensitive information. S3 is great for storing personal PII, for storing health records, for storing confidential information. It can't sit in a VPC. Just by default, it's a region-wide service that doesn't sit inside of VPC. So even if you got your VPC right, make sure you have to go audit your S3 permissions as well. So you can have, you can have up to 100 buckets in an account, and it's very common to have, I see people with billions of objects these days, and it's a really amazing service. They're servicing literally trillions of objects these days out of S3. But the location is across multiple AZs, not housed in a VPC, and there's no way to sit in between a client or attacker and the S3. You really have to view it as there's no way to get in there and sniff what's happening. There's no way to try to block things. It's a storage system. So how you think about security is a little bit different. And they have really, really rich capabilities. Server-side encryption, integration with all kinds of key management systems. They have HTTPS support. They have multiple levels of access control through IAM policies, through bucket policies, through ACLs, through query string authentication. They have server access logs that you can log every access to every file. So they have all the security features you could possibly want. What it is, though, is you have to implement them the right way. It's very easy to accidentally create an IAM policy and open up too much permission to the world. It's very easy to not ever enable server access logs on a bucket with PII in it. So that's your job. There's a shared security model around it, and it's our job as users, consumers of S3 to make sure we're doing all this stuff properly. And time and time again, I go in and I see people granting full control, write ACP, or just plain write. So write access control permissions and write permissions granted to everyone. On any decent sized account, I stumble across things like that. And go turn these off, because they just become multiple security issues. Everything from somebody could use it for file sharing, it can become an economic denial of service attack. It's just never should be allowed to do this. So the other thing is you have to inventory and know where your sensitive data is. So those are the challenges around S3. So RDS can sit within a VPC or not. So again, you should always try to put it in a VPC. It adds such rich security capabilities. If you put it outside of a VPC, it's kind of this new island of its own that can end up being attacked. Ton of security options. So if it's sitting outside of a VPC, they have DB security groups. If it's sitting inside a VPC, they use EC2 VPC security groups. So you have to understand that. Make sure your security groups are set up properly. You can do other things too, defense in depth, things like using non-default database ports, make it a little bit harder for a hacker to stumble across your RDS database. There's an option, publicly accessible option for RDS. Almost never a good idea. So it makes it addressable from the internet, and databases are not designed to be to withstand direct attacks. There's things like what they call zero-day exploits out there, where, for instance, database vendors don't even know about these security holes that attackers have. And with a database, it's just, they're not as robust, for instance, as a web server or an application server, which has gone through much more stringent security reviews, security audits, and they're much more stable and able to withstand attacks. But like a MySQL database, an Oracle database, not something you want to put out in the wild and expose, because if there's something valuable in it and the right hacker comes along, there's plenty of zero-day exploits to kind of grab and take over those type of things. So if you need to use publicly accessible as an option, then do things like make sure your security groups are very restrictive. So this is where every security rule has exceptions. If you're going to have exceptions, make sure that you're putting additional layers of defense to protect yourself. If you're going to put it out there, this may be a good idea to use your database level encryption. And database level encryption is not always a good idea because it affects performance, but these are trade-offs that you have to figure out. So make sure the latest patches are applied, and by that, meaning like if you're running MySQL on RDS, make sure you're using the latest version, because older versions of MySQL have security issues within them. So, and think about this. I mean, what is attacker going? It's not just your RDS database, but where'd you put your snapshots? So if your snapshots aren't secured, they become a major threat surface, because if somebody can get a copy of your snapshot, they can restore it somewhere else, and they've basically created a virtual copy of your database. They could do things on those databases like start brute forcing your passwords there. And that's one of the strategies they'll do, is get a copy of your password hashes, brute force it offline, figure out what the passwords are, and then come attack you. So there's lots of tricks and things, but you want to make sure your database snapshots are just as valuable as the databases themselves. SQS, another service. Where does SQS live? Not within a VPC, it's within a region. So, and you have things like, that's the URL there. So anyone can actually publicly access, can publicly access or attempt to access an SQS queue by going directly to the URL like that. So, and this is based on security on policy documents. So again, a little bit different than your standard IAM. So even if you've gone and reviewed all your IAM policies, you might still have security issues, right? You have to really go deep to make sure you've audited all your things, make sure you don't have everyone granted. And here's a case of where everyone is granted send and receive messages. So you want to make sure you're very careful about not missing these additional layers of IAM, or access controls. Same idea here, SNS, another service that lives outside of VPCs and has a slightly different access control system associated with it. So make sure that you've gone and audited these as well, and make sure that you haven't granted everyone access to any SNS queues. And this is often, it's very easy for us to look at something and say, well, this is just an SNS queue, and how could somebody really attack me and get things out of there? But if you're going to allow people to publish messages to an SNS queue, there's all kinds of vulnerabilities, like can they inject messages in there that have SQL injection attacks in there? So it doesn't attack the queue directly, but when the queue gets put in the database further down somewhere, there's SQL injection attacks. Can they inject something in there that has a cross-site scripting attack? When an admin goes to look at what you put in that queue, it pops up on his screen and runs some JavaScript that sends his credentials somewhere else. So these are very complex attacks, but they exist out there. So never take the attitude or the philosophy mentally that, well, how would anyone ever attack me through an SNS queue that I made everyone public? So they could publish to it. So always take the perspective of somebody clever can figure out how to use this to get into my system. So there's no need to allow everyone to publish SNS topics. So what are the threats? So we often think about what's the threats we hear about are, there's multiple kinds. It's important to understand who is your threat, because how you protect from each threat requires a little bit different philosophy, different controls and monitoring. So for instance, there's internal threats, and this is everything from your disgruntled DevOps guys, a malicious developer, somebody who's going to get fired next week and knows it, or even in the political side, people like Edward Snowden. These are internal threats. These are people that have access. A VPC doesn't actually block these people because these people have access to the system. These people, we need to do things like activity monitoring. And that's where, in the next slide, we're going to talk about CloudTrail. CloudTrail is important. We can't necessarily stop a DevOps, but what we need is the capability to record, understand what they did, monitor it, so we know when they did something malicious, so that we know that we have backups, so that if something truly bad happened, we'd be able to recover from it. So then there's the external threats, which are the very standard, Anonymous or Cult of the Dead Cow or any of these hacker groups, and really where we see a lot of is what I call, or what people call script kiddies, which are the case that somebody's really not attacking you or a specific target. They're just out there roaming through every IP address to find something out there that they can go play with, and it's vandals. It's just and I was in with an organization, a government organization recently, and what's the most common security screw up that people do? EC2 access keys or secret access keys end up in GitHub. Because somebody embedded in a script, and then they want to share it, and it ended up in GitHub, right? And that happens a lot. So one of the premier security analysts out there, guy Rich Mogul, very, very smart guy. He's been doing security for 20 years. He did a blog post about how he accidentally did this, right? And Amazon does a great job because Amazon monitors GitHub, because this happens so often. Amazon monitors GitHubs, and within an hour of you doing it, they'll send you an email and say, "Stop this idiot! Stop it!" They won't. They'll put it differently, but. So they do a great job, but they're constantly getting this happening. I mean, so if a security expert out there doing this 20 years can make this mistake, realize that somebody at your organization is likely to make this mistake at some point. And again, I was at a government, one of the top government agencies for security, a month ago, and this is what happened. Somebody accidentally in one of their accounts published to GitHub their access key, and within an hour, some attacker, some harmless person, came across it, logged into their account, and spun up 400 eight extra larges. So, and again, Amazon did a great job of identifying it immediately, emailing them, they shut it down, all that, but it was still, I don't know, like a $20,000 bill in a couple hours. And they have the soft service limits for a reason, but we all don't want the soft service limits, so this organization got all of them raised, so they were able to spin up 400. But you could see that if top government organizations make these mistakes, that these are the type of things that we have to assume somebody's going to accidentally do it. So what do we do? What kind of protections? What do we do to, when it does happen, to make sure that it's not game over? Right? That's the key, is defense in depth. Assume somebody's going to accidentally publish a key. How dangerous is it? And what are you going to do to minimize the damage? So CloudTrail. CloudTrail is a very cool service, and it records everything that's happening. So, and it supports over 20 AWS services. They still are working on adding a couple more. But they're working as fast as possible. Everything that goes through Amazon, even through the management console, no matter how you access a resource, it gets logged. So that's really an important thing, because it gives you the capability to monitor. It used to be you had a camera in your data center to watch who pulled an EBS volume out of the server and walked out of the building, right? So we don't need that anymore, but it's basically the same thing. CloudTrail gives you the same thing. Anyone that goes in there and picks up an EBS volume and walks out of the building with it, CloudTrail records that by saying every time somebody is copying an EBS volume, anytime anyone's backing up an RDS database, anytime anybody deletes something, it writes it there. So, and there's a lot of different abilities that you have with CloudTrail. For instance, as a hacker, the first thing they would do is try to clean up they'd hack into your system, and then they would immediately delete your CloudTrail files. So there's a lot that Amazon has documented about how do you set this up to be tamper resistant. Tamper resistant meaning in one account, you write to a S3 bucket in a different account, and you only have write capability. So even if somebody does hack this account, they can't go delete their own records. You can still see how they got in, what they did once they got in there, those type of things. So that's the type of technology and the type of process we need in place to really protect. What's the most important thing to monitor in CloudTrail? It's disable CloudTrail, right? So that's because again, that should be the first thing a hacker does when he comes in. It should be disabling CloudTrail, trying to clean those up. And so anytime you see somebody disabling CloudTrail, you should be getting bells and whistles at home, and you should know that something's wrong and that you need to kind of freak out. So that's when you see somebody disable CloudTrail, that's freak out time. So CodeSpaces is an example of how not to end up like CodeSpaces. How many of you guys have heard of CodeSpaces? So I mean, I don't think CodeSpaces did anything wrong. They were probably very good at security and all that, but they didn't think through the whole process of, how do I secure myself? So they actually, so the short story is, somebody got access to their keys, whether it was through GitHub or through an old employee, who knows, but somebody got access to their keys and was able to log onto their management console as an admin, right? So they basically broke into the building and had full control. They were walking around the data center able to pull whatever they wanted, right? That's what giving them access to the management console was. So they went in there to the management console and they left a ransom note and said, pay us this dollars or we're going to cause problems. And CodeSpaces, rather than thinking this through, said, oh, we're going to go disable their account. And of course, this was a smart hacker who, the minute they disabled his account, he deleted everything else in their account because he had the first thing he did when he hacked in was create a second account so that when they disabled his first account, got in through the second account, kind of a virtual backdoor, and just deleted everything. And now they had backups, and everything was backed up to the same account. So what's the lesson that we learn? Which is that if he had a data, they were protected from, okay, an RDS database gets corrupt, I have plenty of backups, but they weren't protected from somebody fat fingering and deleting the whole account, right? Or somebody malicious deleting the whole account. So you have to think through is, if you're, running your entire organization out of a single AWS account, that's not a security technology threat. That's a process threat. That's a people threat. That's that you've exposed yourself in one place to one admin in there can delete everything. And so you have to think through, is that the best strategy? Or do I need to figure out how to segregate that? Or do I have to do a really, really good job of segregating who has IAM permissions to do what in that account? I have to set up multi-factor authentication. I have to do 10 other things to mitigate these risks. But their key was that they didn't have an off-site disaster recovery. They didn't have a second account that they backed up things to. They didn't have any of this stuff. So those are the type of things that they probably did all the right security things. They were using, CloudTrail, blah, 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 but that didn't protect from the real threat, which is somebody getting an access key and then logging on and causing real havoc. So plenty of tools for securing AWS. We provide one of those tools, Cloud Checker. So, you do have to, for instance, if you need antivirus software still on your EC2. You need, these threat protection tools. But beyond that, you need tools that help you at the cloud layer. Now, what's interesting too is as you're this is where it gets complex, is because in an auto-scaling environment, right, if you, for instance, do you have antivirus on each of those tools, on each of those instances, what does that mean? It's not in the old world where when you bought a server, you installed antivirus, you installed a host-based IDS, and then you were done. Now it's like, well, that server comes, it's spun up, it's around for 3 hours, and it goes away. Do you actually register the IDS on it? Do you register the antivirus on it every time it spins up? No, it has to be on it beforehand. And then when it spins up, if it was to get something, what do? Is it registering it back with some central server, or do you just cause it to spin down again? But it's a very different model for how we protect those things. So, but on top of that, you also need to understand, what's happening in your CloudTrail. You need to be monitoring that. You need to be monitoring, your IAM policies, the tools that you use to audit your data center, permissions there, network mapping, don't necessarily make a lot of sense in Amazon. You have to think through, how am I auditing all those IAM permissions? How am I auditing my S3 bucket permissions? How am I auditing my SNS bucket permission, queue permissions? So you really don't just think about the generic tools. Think about purpose-built tools for the cloud. That understand dynamic environments, understand IPs that come and go, things like that. So questions. We have about 10 minutes for questions. If you have questions, I think they want you to come up to the microphones if you have questions and try to speak into it, because this all get recorded. So,
can you recommend any good tools for using those CloudTrail logs?
Yeah, so absolutely. I'll push you guys, come check out Cloud Checker. That's why I'm here ultimately. That's what pays for my trip out here, is come try our tool out for free evaluation at Cloud Checker. Amazon, they have tools to help you set it up, but check out Cloud Checker.
We've used Stackdriver. Actually, we still use Stackdriver,
really?
But either it's not configured properly, it's not catching everything.
Right.
It's not a complete audit trail. I want everything, like that CloudTrail.
Yeah. So Stackdriver is an interesting one. Are we allowed to talk about Stackdriver here, right? Because they're now a Google company.
It's expensive.
Oh, is it real? Okay. Yeah.
They'll throw him out.
Right.
Hey, great presentation, good content.
Thank you.
So I just came from another security session for AWS, and that tended to be very heavy. Seems like the message was more on compliance, which is great. We can be compliant, but we have seen with target breach and all that, you could be PCI compliant, yet bad stuff happen. So my question is, there any best practices guide? Because when you start up a security and all those things that you mentioned is great, but can that be just formulated into a best practice guide as someone who's putting up the workloads up there? What should I do minimally? I do PCI because my customer asked me,
Right.
And I have to, there's a cost to it, and I benefit from that.
Right.
But security as a whole, I don't understand yet what should I do in the first.
Well, so I mean, absolutely, and what it comes down to is people often look for a recipe for security, right? They want 1 cup of sugar and 1 dash of salt. But the truth is, and as you read the PCI compliance, it's all gray. It's all nebulous. They don't define anything, because the truth is, it's really security is an analysis of your situation, balancing the risks with the value of what you're protecting and all that. So, it's very hard to write best practices that meet every requirement. So
let me put it this other way. So when you do a PCI, the auditor tells me controls 5, 6, 7, do this, do IPS, do encryption and stuff like that. I know how to follow that.
right.
But just to protect myself from breach, like you mentioned about the keys on GitHub and things like that, I don't see so the reason I'm on AWS is it gives me a lot of recipe to do things. What database to use, what EC2, how much I can size my workloads and things like that. There's recipes for all those.
Right.
The securities, there's a gap for that. I do need a recipe, exactly.
Right, yeah. So Amazon has some great best practice white papers definitely out there for security. I still don't think they give you a checkbox recipe. At the end of the day, you have to assess your situation and figure it out. But they do have some awesome best practice white papers. And I say, just go Google them, and you're going to find a bunch of them. So.
Oh, great.
Yeah.
Thank you.
You're welcome.
Hello. Thanks for good recommendations. I have a lot of to do after your presentation.
Thank you.
Question. Is it a good idea to deploy virtual IPS appliance, or AWS is good enough and it would be overkill?
You're talking about IPS?
Yes.
IPS is a tough one. I mean, so it is a good idea to put IPS, inline, IDS systems, WAF, web application firewalls. I think that's all a great idea. But it's a single layer of defense. And if you put that on the one avenue into your network, the hackers just come through the other avenues. So I think it's a good layer of defense, but it's one of 5 layers you ought to have. So, and they are complicated to install and set up. They're expensive, but you should have them if you have a public website. But they certainly shouldn't be your only thing you're setting up.
Okay. Yeah. Thanks.
You're welcome.
Is there any best practice or recommendation for sending to my printer that is sitting in my office from a website that is running in AWS?
Sending a what?
For documents to print in my printer, the printer is sitting in my office, from a website application that is in AWS, is there a better recommendation or to print it?
I don't
Other than
know.
opening a port, or right now we do is open a port, and then I feel like it's a little insecure to open a port to come and print in my printer that is sitting in my office.
I don't know much about what protocols they use. I mean, I assume that they have a protocol that uses SSL. I assume, and you probably do have to open a port if you want to do that. But can you restrict it to the IP address of the whoever's coming in? So yeah, it's a very standard. Your port. Your firewall ends up becoming Swiss cheese, right? Because here's a port for printing, and here's a port for this other application. All of a sudden, I have 100 open ports, and I can't even remember why I opened any of them. Yeah. I don't know of a better. Anyone else know of a more secure way to do that? Maybe you could talk to him. I don't know off the top of my head a better way to. So, don't print it. Get a Kindle.
Just these barcode printers, zebras, yeah.
Yeah.
Silly question. Where could I get the slides?
Well, I know this is going to be on YouTube. If you want to give me a card afterwards, I can send you the slides specifically. I don't know if they are making the slides available, but they're putting this on YouTube, definitely. But if you give me a card afterwards, I'll send you the slides directly.
Well, thanks.
You're welcome.
I have a question for the intensely paranoid amongst us. What kind of relationship does Amazon have with any government 3-letter agencies?
Well, I mean, Amazon hosts C2S, which that's the CIA, and they're hosting their cloud. So I think they have a strong relationship, but I don't think that there's anything going on like what did with Facebook and anything like that. But I don't know.
Are there any particular Amazon zones that one should be in?
Yeah, C2S is run in its own very own region, so it doesn't interact. For instance, it's actually air-gapped itself. So from C2S, you have no connection to the outside world. But I mean, we can't get in anyways. It's only the intelligence
I
community.
was asking the reverse question. Suppose I didn't want to participate in any NSA programs. Is there a specific Amazon zone maybe that's located outside of the U.S. that isn't subject to PRISM?
Yeah, I mean, there's 7 zones or 6 zones outside of the U.S. You can go to the AWS China zone in Beijing.
Nice. That might have a different problem.
Right.
Is there a public policy about that? Does Amazon publish any of that information?
I actually don't know. I mean, that's more of a political question than anything else. Does anyone know what Amazon's policy? I'm sure their policy is that no, they're not giving NSA access to all your data. I'm sure, but I have no idea whether. I'm sure that was also Facebook's policies and everybody else's policies.
It's probably impossible to separate security from politics, though, don't you think?
Yes, probably, yes.
The fight was about transparency. So people that are...
Do you want, they want me to tell you to go to the speaker.
The follow-on to that, other information is that some people have announced that they want more transparency. So when they're ordered by the government to turn over information, they want to be able to report that to the public.
Right.
So I don't know if that's the case in Amazon, but...
Yeah. So I got to end, so if you have more questions, feel free to come up. But thanks everyone for coming.